Page 309, section 6.3 is on analyzing rotations. So we're going to look at how does a rotation affect the properties of a two-dimensional figure. So if you look at an example 1, they're talking about rotating an umbrella, and it has this umbrella. They can be rotated so clients can either enjoy the sun or the shade. So you can look on the umbrella and you can see, I'm not sure what's really what here for sure, but you can see the little lines going across on the one part of the umbrella, so we can distinguish where it is now and where it is after we rotate it. Rotation, think about rotating something, it's like turning it. So rotation turns a figure around a fixed point, called the center of rotation. In this case, what we're going to be mainly looking at is looking at points on a graph, and our center of rotation is going to be the origin. It's going to be the point 0, 0. Okay, but anyway, for right now we're looking at this umbrella, and the angle of rotation is how many degrees the figure rotates. And I don't know why they do it this way, but if we go counterclockwise, that's considered to be a positive angle of rotation. So we're always going to think about turning things counterclockwise, so the opposite way of how the hands on a clock move, okay, is counterclockwise. So it tells us here the architect rotates the umbrella 90 degrees counterclockwise. So you can see here it was to start with. So if we move 90 degrees counterclockwise, would be going like this, okay? And if it helps you to draw out a clock and go backwards on the clock, okay, sometimes I have to think about it a little bit myself. So what we're going to do is look at how many degrees you move starting from the original point going to the new point. That's one way of doing this. What we're going to do more so is actually use tracing paper, and I'll show you how that's going to work, that we can use tracing paper to help us figure these out. So example 2, what are the coordinates of the image of trapezoid ABCD after a 90 degree rotation about the origin? So ABCD is our starting, you can see, and we're rotating it 90 degrees about the origin. So what I'm going to do is I'm going to draw a line on the x-axis and the y-axis, and these would be things you would be tracing on your tracing paper. And then we can put points and letters and go ahead and even connect those points. Okay, so if we do all that, and then we can think about if we're going to rotate this 90 degrees, we want to go 90 degrees counterclockwise. So what we're going to do is just turn this until those lines match up. Once the lines match up again, that's a 90 degree rotation. And you can see that puts us exactly where the book had those points. Okay? Now if you were doing this on tracing paper and that wasn't drawn there yet, what you could do is even just, if you wanted to, poke holes through your tracing paper at those spots so that you could mark the spots and then you could label them. And then just make sure you remember, like the book did here, since those are new points, then we can put primes. We'll want to put primes on them to show that they're the new points versus the original points. So the book gives all this stuff about, you know, if we do a 90-degree rotation, switch the X and the Y, and then it's the opposite of what the Y value was and all this stuff. It's really, to me, just kind of too complicated to think about. We could memorize it, but I don't know that it really provides an advantage over just using tracing paper or drawing it and turning it. So if you look at the try it, we have these points and we're rotating it 270 degrees. What are the vertices of the resulting image? This quadrilateral. Okay, so this would be something in this case where we would want to first graph this on graphing paper, and then we can use our tracing paper and rotate it. So we graph our points here, 1, 4. 3, 2. -1, -4, and -3, -2. One thing I haven't mentioned yet is when you go to graph these and then you rotate it, your rotation is not going to change the size of it. Just by turning it, the size is going to stay the same. Okay? So that's something else you can watch for. I'm not going to be able to do it on this one very well because I'm going to make this where I'm going to be turning actually my original figure here. Okay, so we're going to rotate this 270 degrees. So 270 counterclockwise. So here's 90. Whoops. 180 and 270. Okay, so this would be my final graph, and then at that point, you know, I just want to make sure I label these points. This is I prime, H prime, K prime, and J prime. Okay, that would be what it would look like. Like I said, if you graph it on graph paper and then trace it on your tracing paper and then turn it, you'll be able to see both of those, the original and the new graph, what those look like. And technically it says what are the vertices of the point, so they're actually asking what the coordinates are. So you'd have to say H prime is 4, -1, I prime is 2, -3, J prime is -4, 1, and K prime is -2, 3. Example 3, they want us to describe the rotation that happens here. And the book just, you know, looks at these and they say, oh, that's a 270-degree rotation. That's fine. If you want to use this with tracing paper, though, we can do that like we've been doing. You can draw the original figure. One thing that's always a good idea, like I mentioned, is to actually write the letters as well. And then that way you can make sure it's actually turned how you want it to be. So this would be, if you go to turn this counterclockwise, there's 90, (180) and 270. We're just adding 90 degrees every time we turn and get those lines to match up. And then just make sure that your letters are in the same spots where they should be. Okay, so the try it's basically the same idea. They want us to tell what's the rotation that happened here. So we'll just do the same thing. One thing to make sure of is that you start with the original points, which are the ones that don't have the primes on them. Okay, so we're going counterclockwise, so this would be, whoops, I forgot to lock my size on this thing. So that would be 90 degrees, and that would be 180 degrees. And I'm off a little bit just because I didn't have it locked to begin with, but you can see that would be what we want. So that would be 180 degrees. 180 degree rotation. And the book might say it's 180 degree rotation about the origin. Okay. It's always going to be about the origin. We're always rotating around that origin, the point 0, 0, when we do these problems. So if you look at the do you know how number 4, we're taking those points and we're rotating them 90 degrees. And what would the new coordinates be? And so once again, that would be just actually graphing that and then rotating it. So here would be our points to start with. And then if we rotate it 90 degrees, that's going to be counterclockwise. Thought I had this done right, but maybe not. So if we rotate this 90 degrees, counterclockwise is going this way. And then we could just say what our new coordinates are. So it'd be A prime. A prime would be 2, 3. B prime would be -2, 3. C prime would be -2, -3. D prime would be 2, -3. And then they ask what the measures of the angles are. It told us in the problem that it's a rectangle, so the measures of the angle would all be 90 degrees. So if we look at number 5, they want us to describe the counterclockwise rotation that maps this. So we can trace these. Make sure you trace the original figure. And then we're rotating counterclockwise, so it's 90, 180, and 270 would be. Okay, so this would be a 270 degree counterclockwise rotation, which if we it's assumed that it's counterclockwise unless we say otherwise. So this gives you an idea of how to work with rotations. Have a good day.